Welcome, everybody, to this Data Center Knowledge Fast Chat. I'm really happy to have you here today. I am Bill Clayman, EVP of Digital Solutions over at Switch and the contributing editor over at Data Center Knowledge. And I am joined by an absolutely fantastic team today. Joining me are Dan Cerulli, VP of Product, Eric Good, Principal Architect, and Toby Knaup, CEO, all from D2iQ. Welcome. It is really great to have you all here.
Great to be here, Bill.
Thanks for having us.
Thank you.
It's so exciting, right? I'm just so stoked to jump into this conversation because I love the world of DevOps, and I've had a chance to work with things like Kubernetes, and we've heard about things like AWS, Elastic Kubernetes services. And the one thing in my experience that I've seen is the capability for these kinds of solutions to give a customer a really amazing Kubernetes platform and base. It gives companies this capability to deliver a richer set of product level capabilities that meet and supplement EKS with additional add-on services. But here's the thing, DevOps and development is at the top of so many minds today. And the challenge is, it's not always as easy as people make it out to be. So we are going to just jump right into this conversation. That's why they call this a fast chat. And Dan, I hope you're nice and ready, right? We're gonna start with you. When people think they're ready to move to Kubernetes, right? They get so excited, they jump right into the concept of technology, and they're like, "All right, we're gonna deploy all of this, and we're gonna be professionals at it." But Dan, is that ultimately really accurate? Are they really ready to push this thing to production? What do you think they're missing?
So I think the thing is, people understand they've got to containerize their app. They've got to figure out how to do that. And that's kind of a solved problem. The managed Kubernetes services like EKS are fantastic because Kubernetes is hard. Installing it is hard, and they get it out of the box, right? The mistake that people don't, the thing they don't understand is that when you turn up that EKS cluster and you deploy your containerized app to it, it runs, but it's not ready for production. There's a lot of problems that you still need to solve. You still need to make sure things are secure. You need to understand what you're doing for logging, what you're doing for monitoring, what you're doing for compliance, how you're going to control who has access to what. All of those things need to be solved before you can truly put an app into production. And one of the mistakes people make is they think, okay, we're on Kubernetes, we're ready, let's go. There's still a lot more work to be done that EKS alone doesn't solve for you.
Absolutely brilliant. So just because it works doesn't necessarily mean it's working right. That is an amazing concept, and I love it. Toby, we're gonna bring you in here, and I'm really excited because we were having a wonderful pre-call conversation here. All right. Once they're successful, here's the good news and the bad news. The good news, Kubernetes is amazing. The bad news is it's going to spread like wildfire and everyone's going to want to use it. Everyone wants to deploy applications faster, more streamlined. Services are becoming way more effective. But here's a really important question. Toby, what happens when organizations see so much success that they start to see Kubernetes sprawl?
Yeah, Kubernetes sprawl is the new VM sprawl. It's real. And so, especially with Kubernetes, which is really gives people a lot of power to sort of self-serve and like run their own apps, it really spreads very quickly. Other teams look at that first Kubernetes team and say like, well, I want to move as fast as these guys. I want to have a platform that's as resilient as what they're doing. I don't want to get paged at 3 a.m. like these guys. And so it really spreads very quickly. And what we see in a lot of organizations is that, well, all of a sudden they have a dozen ways to stand up Kubernetes and to manage Kubernetes on day 2. And of course, that's not a great thing, right? To have 12 different ways to do one thing. And so what's really critical is to have, capabilities that allow you to manage your entire fleet of Kubernetes from a single control plane, like our DKP product. And so all of those capabilities that Dan was just talking about that you need to do on day 2, like access control, governance, observability, and even lifecycle managing the clusters themselves. We have a really nice repeatable way to do that across your entire fleet using amazing technologies like Cluster API, for example.
Toby, brilliant. And I think what you just did is amazing because it's a perfect segue in our next conversation, specifically talking about APIs. And I want everyone to think about this because, these technologies are great and Kubernetes is awesome, right? But it does spread very quickly because it's a powerful technology. The last thing that you want is to be in an environment that's poorly managed. But let's kind of stay on that a little bit. Eric, I hope you're nice and ready, because you and me are going to pop the hood on this, and we're going to dive into the weeds a little bit. We're going to have some fun. And I want to stay on this topic here a little bit. You mentioned it, Toby, right? Nobody wants to be up at 3 o'clock in the morning, cold, beat up sweat flowing down your face, trying to figure out who pressed what button in these early hours in the morning, right? Or worse yet, which button was pressed wrong. So, Eric, here's my question. How do you streamline these processes? I also feel that things like security is a challenge in terms of access and management. So ultimately, what tools and capabilities are out there to make this easier?
Yeah, like Toby mentioned, as your number of clusters get bigger and the sprawl gets bigger and bigger, how do you manage this kind of stuff? And a lot of that comes down to GitOps and the whole declarative process behind Cluster API. Mm-hmm. So in essence, when you're deploying apps, everybody knows you deploy your apps, everything is an object within Kubernetes. But here, your Kubernetes cluster becomes an object itself. You store that in Git. You can see the differences. It gets pushed through a CD tool. We have a customer now that they've got the whole process down to a fully declarative process for all of their clusters within AWS. And it's just a ServiceNow ticket to stand up a whole new cluster. A few approvals, everything goes through the pipeline, and boom, you've got a new cluster.
I think that's extraordinary, right? And I think that's so important, Eric, that you just mentioned this, is you have to think practically, how do I deploy these critical technologies in a more effective manner? I want to stay in this in terms of efficacy. Toby, let's start with you here a little bit. You're a leader in this industry, and I've known D2iQ for some time, and I've seen what you've been able to develop. Leaders, executives, and I'm talking to you right now, people out there in the management suite, you want to be able to use data services, deploy applications as effectively as humanly possible. But then you want to be able to analyze this data and capitalize on new and emerging advanced technologies. We're talking about data warehouses, data lakes, and utilize advanced tech like AI and machine learning. Here's my question, Toby. What are leaders, and how are leaders doing this today?
Yeah, it's a great question. So a lot of companies, organizations we work with they're really building what's next. They're building cutting edge products in whatever space they're in. And we see a lot of organizations go through a journey when they adopt cloud native. First they're building some fairly simple apps, business logic, and then they add data capabilities. And once they have that data, they really want to gain insights into that data and build data-driven products and AI and ML-driven products. Because those products, that AI attribute is going to be a key attribute of the winning products of tomorrow. So we know about self-driving cars and how AI does that, but there's examples everywhere, right? AI makes MRI scanners better and many, many other examples. So how they're doing it is they're really thinking about making AI and ML capabilities part of that same application that they're building using containers and using Kubernetes. And it turns out these applications, these AI applications, are pretty operationally complex. There's actually a lot of pieces that go into it. It's not just a single workload. It's typically over a dozen workloads that need to come together to build, an AI pipeline. Well, it turns out Kubernetes and containers are just really good at managing, this sort of hodgepodge of different applications and making sure it all works together.
Toby, I'm going to put you on the spot here for a second, and I'm going to ask you a question that I think is both fun and challenging. In your experience, where have you seen these kinds of Kubernetes projects and these data-related services projects fail?
Yeah, I think we made a really interesting observation there, because you might think that, AI, it's this crazy complicated technology, and I need to hire a whole bunch of people with AI PhDs to do something. It turns out that's actually not the biggest problem that most organizations have. They typically really understand their data well that they have in their space, and what they might do with it and how they might build a model. But where over 80% of machine learning projects fail is actually on their way to production. Wow. So they have the data, they built a model, the model gives them some really awesome insights, but they don't know how to productionize it. How do you take that model and run it like a production service that's always available 24/7, that's performant, and so forth? And we solved that problem for other containerized workloads, right? For putting microservices into production. How do we monitor those? How do we use CI, CD, blue-green deployments? Well, it turns out you can actually apply all of those same methodologies and technologies to AI models too, and move them into production that way. So that's what makes Kubernetes a really good platform for AI and ML workloads too.
My brain's going a million miles an hour right now, Toby. I wish we had like 2 hours to talk about this because I think your point on 80% of these projects fail on their way to deployment. My gosh, that's got to be so heartbreaking, right? So much effort and work to be put in, not to be just not to be deployed, right? So I think these tools are critical to both put a light on this challenge and how to overcome it. I want to talk about some of the positives here. So Dan, I'm gonna jump in with you. Do you have, or can you talk about some? I'm sorry, Eric. Let's actually talk with you really. You mentioned some customer use cases earlier. Maybe you can talk about a couple more. You don't have to name any customers, I promise. But how do new deployment methodologies help simplify the barrier to access to things like what Toby was talking about, like AI and machine learning?
Sure. Like he said, these workloads, they're very elastic. They come and go, they're transient. You might run a model that runs for days even, but then it goes away. And what about all that hardware in the meantime? Or what if you want to try a new experiment? And one of the things that, our product allows you to do is to do like node auto scaling. And that's the example that I gave earlier. One of our customers, they're in the cloud. They want to buy their own hardware. They can't get it yet. It's super expensive. It's not available. So they're in the cloud. And these A100 NVIDIA machines are costing them, $20,000+ a month. I mean, that's a lot of money when you just throw it out there. But their developers aren't working in the middle of the night. If they don't have a model that doesn't take days to run, what do we do with those nodes? And with our platform, we were able to create an environment where they can scale those nodes down and not pay for those servers when they didn't need them. So even the Kubernetes cluster itself becomes very elastic.
That is so cool. Like I had like a second of silence, just like ingest all that information. I think that's really nifty. And I definitely think that's a success point, right? Being able to scale and make an elastic Kubernetes element. All right, Dan. I know I called on you earlier, but now it's definitely your turn to contribute some thoughts. And I want to stay on this topic of success, right? Success stories. What are organizations doing to be successful in their deployments so that we don't hit that 80% scary number that Toby was talking about? So what are organizations doing to find success?
So there's a lot of things. You have to really understand your use case and understand what pieces you're going to need to put into place. And sometimes that means, take, for example, security. Understand, depending on what you're doing, are you a government? Are you enterprise? Are you financial services? Is security very important? Mm-hmm. You have to be able to put whatever it needs to be in place. And that might mean overlaying something like a service mesh so that you can use MTLS point-to-point, encrypt everything in transit. It might mean that you need an API gateway securing traffic in, but it might mean that your application is sensitive enough that you can't allow any connection to the internet at all. We call that an air-gapped deployment. Sometimes it's literally air-gapped in the government. That's not uncommon at all. But even in financial services, or maybe on a cruise ship, you've got a Kubernetes cluster that's running that either cannot or may not connect to the internet. And in that case, you need to ensure that you have a production deployment. Say you don't have an application that's trying to reach out to something to grab an image, because Kubernetes, typically you're grabbing an image repo, right? You need to make sure you're logging, you're monitoring. All of those things are suited to the use case that you are putting into place so that you can achieve success.
I'm so grateful that you mentioned that in terms of success, right? It's not just deploying an amazing cluster that's elastic, it's also deploying one that's secure. Everybody listening, Dan talked about some really important things, being able to control access. And Eric, you mentioned this as well. And things like air gapping, right? This is a real practice that people need to employ. And Dan, it sounds like that's what from what you're seeing is what organizations are doing to ensure Kubernetes cluster security. I think that's absolutely brilliant. Remarkably, we're coming up to the end of our fast chat, and obviously, since it feels like it flew by, that's the point of a fast chat, but it's also because we're having a really great conversation. We're going to start to wrap this up. I'm going to ask the panelists here for some final thoughts, right? These are going to be rapid fire questions and answers. Eric, you're on the hot seat. We're gonna start with you. From a technical perspective, can you give some really good points about modernizing legacy applications? I know we didn't talk about that too much, and how Kubernetes is helping gain agility and a really important concept that I think is important for engineers all the way to the executive team, the ability to go to speed to market.
Right. So Kubernetes gives you kind of the elastic ability that you need to, like, for developers to experiment or for teams to experiment with different things and actually fail fast or even throw stuff away. Everybody's like, ooh, don't throw things away. But like, because, we paid for it. But like, ultimately, sometimes something doesn't go right and it's easier to throw it away. And when you have an elastic environment like Kubernetes, you can throw a new application up there in a set of pods. And if it doesn't work, then you get rid of it, or you expand it, or you change it. And so it gets rid of that barrier to entry for teams to experiment and try new things and innovate. And that's super important for engineering teams and development groups as a whole.
Brilliant. Absolutely brilliant, Eric. I hope everyone takes that away too. Dan, I'm excited about this question because I think it's near and dear to me, at least. I wrote an article on Data Center Knowledge's sister site Information Week a little while ago called DevOps 101, where literally in the beginning, I try to drill in the concept that DevOps is not one thing. It's truly an all-encompassing process and concept and tool set, et cetera, et cetera. But honestly, one of the most important part of that is people. Right. And so the question, Dan, I've got for you is, how do these tools that we've been talking about, the technology from D2iQ, how is that helping, quote, bring your people along?
I think it's important. I'm really glad you mentioned it, Bill, because I think it's one thing to understand that technology alone doesn't make this happen in any enterprise, in any company. You need to have your people there too. And that means, one, making sure that you've got one team, right? It's dev, it's ops, it's DevOps. You're going to have to be one team, and you're all going to have to be trying to accomplish the same thing. And you're going to need to learn new things, right? The biggest problem in Kubernetes, look at any survey, is hiring. Everyone says that, right? Well, the fact is you can't hire a whole new workforce. So just saying what you said is the most important thing. Understand you are going to have to bring your people along. Bring them trainings, help educate them on these new platforms. The people that you have today, they can do this. They can make this transition to hybrid, to multi-cloud, to cloud native, to technologies like Kubernetes and DKP. But bring the trainings in, let them understand how this is going to affect them, how it's going to make them more productive at their jobs. And that will be instrumental in helping you succeed.
I think that's so critical. And you said something that I want everybody listening to this to take away, introspectively. Technology alone can't solve the problem. You have to bring your people along. And I think that's critical, the tools that you choose and what you work with. And again, as a part of talking about, people and process and technology, Toby, let's pass this on to you to give us a strong wrap up here. We talked about people, process, and technology, and how important it is to have those pieces together to bring your people along. I'm going to ask you this final question. How do these kinds of tools that we've been talking about in the concept of people, process, and technology help organizations of all sizes jumpstart cloud native solutions to help their businesses be more agile in today's market?
Yeah, absolutely. So, we talk a lot about day two and day two operations and, all the value we're adding there. But, the reality is a lot of organizations struggle to even get to day one with cloud native, to get their first application up and running. They spent many months doing that to get the platform ready, to get the first application running. And the reason is because I think they sometimes or often underestimate sort of what needs to be built around the technologies. If you look at the cloud native landscape, you look at this and you'll say like, oh my God, all the Lego pieces are there. I have things for networking, for storage, for observability, for security, right? It's all there. But they underestimate the amount of work that it takes to actually put those pieces together and to automate the operations of those pieces, right? So a big part of the value that a platform like DKP adds is we automate the operation of all those pieces and the integration. So what we're actually doing is we're taking that concept that Kubernetes really champions, which is declarative APIs and controllers to do the work, and applying that to not just your applications, but to the platform itself, starting all the way in the beginning with standing up Kubernetes, as we talked about, including things like EKS. And so that really takes those many months to get your first application up and running down to a matter of hours. So you can have your first app up and running on the same day. You can get your experience with that. And then, like we talked about, it spreads like wildfire from there.
Brilliant. And a perfect segue into our wrap up conversation here, Toby. Thank you for those insights. We've heard so much, everybody, and so many good, insightful comments and thoughts about working with cloud native solutions. Thank you so much to Eric, Dan, and Toby from D2iQ for your amazing insights. And to wrap it up, everybody, some action items, homework for all of you to take back with you. Number one, engage the D2iQ experts. They've got so much knowledge. They can help you out with a lot of these complex DevOps challenges you might be facing. Utilize information that's on the D2iQ website. That's D2, the number 2, IQ.com. And you can find some more case studies that Eric talked about, solutions briefs, some cheat sheets, FAQs, and ultimately, honestly, my favorite as a practitioner that likes to get his hands dirty, ask for a demo, try this stuff out, validate everything that Toby, Eric, and Dan are saying, and then see how it can fit into your organization. And with that, for Data Center Knowledge, I'm Bill Clayman. Thank you, everybody, for joining us today. And again, big thank you to Eric, Dan, and Toby for hanging out with us for a little bit today.
Thanks for having us on.
Thank you.
Thanks, Bill.